So we are looking at practical problems in algebra. So these will be problems that usually have a lot of words. They're talking about real life situations, and they don't give us an equation, but we have to come up with an equation to actually solve the problem. So there are a couple steps to take when given practical problems and being asked to solve them. And the first step is to identify the important information. Identify the important information. So that's going to be any numbers, any variables that they tell us, just anything about the problem that we think is important. And we can ignore the irrelevant details. So we'll talk about in some of our examples what irrelevant details look like. Step 2 is we need to define the variable. So define the variable, or if there's multiple variables. So we're going to define the variable and what may go with them. So for example, we might have some coefficients. The next thing we're going to define is any constants. So these are numbers that don't change. So a lot of times in real life problems, they might say a one-time fee or a down payment, something that doesn't change. It's not going to have a variable associated with it. Once we've defined our variables and defined our constants, the last step is to define the relationship between the variables and constants. So what I mean by that is that are we adding things, are we subtracting, are we dividing, multiplying, or are we setting things equal to each other? We're defining that relationship and creating an equation. Once we create that equation, then we can actually solve for whatever the question's asking for. Okay, so solve for whatever it's asking for. So let's take these steps through an example. Here we go. Jacob B. Jacob B decided to start working a part-time job. He gets a base salary of $57.50, $57.50 a day, plus $2.50 for each sale he makes. How many sales does he need to make to earn $157.50? So going through our steps, we need to identify important information and ignore irrelevant details. So let's just highlight important information. So it seems important that he gets paid a base salary of that much a day, plus $2.50 for each sale he makes. They want to know how many sales does he need to earn this much money. Say how many sales. So that's what we're looking for. Looking for how many sales he needs to make. Okay, the next step was to identify our variables. So variables. They don't always tell you like x, let x equal what, x equal something, or t equal time, h equal hours, whatever. They don't always say that. Sometimes they do. But let's look at, in this example, what changes. What's our unknown? What are we looking for? Well, we're looking for how many sales he makes. And he makes $2.50 for each sale. So our variables is going to be something representing the number of sales, and we can just say this is S. S represents the number of sales. If you don't like S, you can use X, doesn't matter. So what is constant? Okay, what remains the same? While his number of sales changes, something stays the same. Well, he has a base salary of $57.50. That's his base salary. That does not change. So that's going to be a constant. If our variable is S, for sales, what could we put with that variable S? What do we know about sales? We know that he makes $2.50 per sale. So we can actually use that as a coefficient, 250S, and then a constant, 5750. We've identified our variable, we've defined our constants. Now we're going to define the relationship between the variables and the constants. And once we do that, we can solve. So if our variable is 250S, that's how much he makes an hour. And the constant is that 5750, that's what he makes when he walks in the door each day. And then he needs to earn a total of this much. How can we relate those numbers together? Are we just going to multiply them all? Are we going to add them, subtract them? What are we going to do? Well, let's think about what it's saying. He walks in and he makes $57.50 per day, plus $2.50 for every sale. We want to know how many sales does he need to make a total of $157.50 in one day. So the relationship is that we're adding our constant and our coefficient with our variable to equal a total of this much. So now we have an equation that we can solve. So let's do that. It's just a two-step equation. Subtract 5750 on both sides. And we're left with 250s equals 100. From here, we're going to divide both sides by 250. And we find that S equals what? S equals 40. So our answer needs to be in terms of the question being asked. How many sales does he need to make to earn that money? So he needs to make 40 sales. So that would be our answer, 40 sales. In this next one, we're looking at Mr. LaValle, and he enjoys Taco Bell soft tacos. They're running a special where each taco costs 69 cents each, plus a quesadilla for $3.45. His bill was $24.15. How many tacos did he eat? So let's identify important information, and we're going to ignore irrelevant. So it's pretty irrelevant that it's Mr. LaValle and that we're going to Taco Bell, even the fact that it's about tacos, but it is relevant that they're saying it's 69 cents each, plus a quesadilla for $3.45. Doesn't really matter that it's a quesadilla. The fact is it's a separate cost. His total bill was $25.15. And then the question they ask is how many tacos did he eat? So let's identify our variable and our constants. Okay. So variable, what changes? Well, the thing that changes is the number of tacos, and that's actually what they're asking us to look for. So we're going to say T. And it's important that we put the cost of each taco with the variable. So that's 69 cents T, so 0.69 T. What's constant? Well, he's going to buy one quesadilla, that's $3.45, and that does not change. That's a one-time payment. And it's really important that his final bill is $24.15. So let's put the relationship between these variables and constants together into an equation. So thinking about how much he spends, well, he's going to spend 69 cents or 0.69 T per taco plus a one-time fee of $3.45 for the quesadilla, and he's going to spend a total of $24.15. How many tacos did he eat? So we're going to solve for T. So we're just setting up our two-step equation. Subtract $3.45 on both sides. You get 2070 to 24.15 minus 3.45, and we're going to divide that by 0.69. To find the total amount of tacos that he buys. So write your answer in terms of the question being asked. It's not just T equals 30, it's 30 tacos. So Mr. LaValle can buy 30 tacos for that amount. Our next question is talking about Miss Hamby, and she's thinking about buying a pizza. She's looking at Papa John's. Papa John's charges $8 per pizza, so that's important. So I'm going to highlight that, $8 per pizza, plus $5 for delivery. Pizza Hut charges $6 per pizza, plus $9 for delivery. How many pizzas? How many pizzas? So that's what we're looking for, pizzas. Should Miss Hamby order in order to pay the same amount at both places? So this is actually a really good scenario for if you have a set amount of money that you want to spend and you want to know which place has a better deal, which place is going to get me more pizzas. So let's define our variables and our constants. There's actually two situations going on. We have the Papa John's situation and then the Pizza Hut situation. So we're going to separate them a little bit. So looking at Papa John's, they charge $8 per pizza. So $8 is going to change for every pizza that you buy. And then it charges a constant $5 for delivery. So our variable in this case is going to be P. Pizza Hut charges $6 per pizza. So that's what changes per pizza, plus a constant $9 one-time fee for delivery. So how are these related to each other? Well, Papa John's is going to charge $8 per pizza plus $5 for delivery. Pizza Hut charges $6 per pizza, or 6p, plus $9 for delivery. Now, we've got two different expressions. Are we just going to add them together? What are we going to do? They say how many pizzas should Miss Hamby order in order to pay the same amount at both places? When I see same amount, an equal sign should be flashing in my brain. We want to set them equal to each other. This looks different than the previous two examples. In the previous two, we just set them equal to a number, but in this occasion, we're setting two expressions equal to each other. And that's okay. We know how to solve this. This is a multi-step equation. So we can subtract 6p, subtract 6p, 2p plus 5 is equal to 9. So 2p is equal to 4. P is equal to 2 because we divided both by 2. So our answer is not p equals 2, it's 2 pizzas. If she orders 2 pizzas from either place, it'll be the same amount of money. Kyle and Kaylee are having a soccer fundraiser. It's not really important that it's a soccer fundraiser, but the money is important. Kyle raises $7 per mile that he runs, plus $4 just for showing up. Okay. Kaylee raises $6 per mile that she runs, plus $9 for showing up. Okay. If they raise the same amount of money, how many miles did they run? Okay, so how many miles? So that's talking about our variable. So let's compare situations. I've got variable terms and we've got constant terms. And there's two situations. There's Kyle and then there's Kaylee. Kyle, variable. What changes? The miles. He's going to make $7 per mile plus $4 just for showing up. So we'll say that M miles is our variable. Kaylee makes $6 per mile, and then she gets $9 raised just for doing the run. So how are we going to relate these? Kyle gets $7 per mile plus $4 for showing up. Kaylee is $6 per mile plus $9 for showing up. We want to know how many miles means that they run the same amount, so let's do that math. M plus 4 equals 9. So we'll subtract 4 on both sides, and we get M equals 5. That's not the answer, though. We need to say 5 miles.